Start this recording. All right, so everybody can see, right? So this is just the general BCC website. Like this, I'm just showing y'all something real quick. You go right here to quick links. You have your bright space here, your CUNY first, right? So anybody have trouble? I know some people just walked in. Anybody have trouble logging in? Anybody want to talk about it? All right. So for CUNY first, right? You're gonna have to set up this two-factor authentication thing. All right. Um, Truthfully speaking, I don't have the power to help y'all do that because like the IT people have extra powers. But what I'd like to tell you is where to go. Right. So the IT service is at Roscoe Brown on the third floor. Right. Roscoe Brown is a place where you guys went to get your IDs. If you guys didn't get your IDs yet. All right. They can also help you set up your email, which you see right here. This is how you get to the email. In case you guys want to send me an email or anything like that. All right. I'm a fan of Microsoft Teams. Everybody here has 365. If you guys ever tried Microsoft Teams, you guys can message me there and I'll message you back, no problem. All right. Um, what else can I talk about here? So Roscoe Brown, third floor. There'll be other things throughout the semester that might come across my email, and I might just like shoot that out to you guys. Just like little goodies of information, things like that. Another thing I could talk to you all about is the ARC Resource Center. So just going over some benefits of BCC a little bit, some resources, right? So should I say center? Does that make that a difference? Hold on. It's loading. I guess a lot of people are using Wi-Fi now. Here we go. So this is a place that you can go on campus as well. It is in Low Hall on the fourth floor, right? And this is some of the things that they do. Like if you guys ever need like help with SNAP or you need like financial services, legal services, tax preparation. I personally do my taxes here every year, to be honest with you. All right. Just letting you guys know about that. They also have a pantry. They do all of that. All you have to do is just search for their intake form, ARC intake form, this thing. You just click here and fill it out. It's a little lengthy, to be honest with you. Like it's not a 2-minute form. This might be like a 3-minute form. All right. But you fill that out and you could take advantage of all of the benefits that they have. All right. So there's that. Um, let's talk about disability services, right? So if anybody here is allowed accommodations or you guys had accommodations in high school, right? You guys can go to disability service and register with them to get your accommodations, right? Accommodations like if you need like extra time or if you need like that don't really matter to y'all because y'all all gonna get calculators, but whatever, you can just go there. Yeah, yeah. It helps if you have one. If you don't have one, then you got to go through some process to get one or whatever. If you guys want to take advantage of the service, take advantage of the service. If not, it's okay. All right. So that's that. All right. Doo, doo, doo. 1 second. All right. I'm gonna send you guys out a detailed instruction about web work. All right. But WebWork is going to be the platform that we use to do our homework, right? There's a particular way to log in with it. It's going to be your first name and then your last name in all lowercase letters, right? And you just type in, and that's your username and your password, right? But again, I'm gonna send you out an announcement that's gonna detail that. Did everybody get my announcement for today? Yeah, no? All right, so you see it now? All right. That's fine. That's fine. I'll take that. So, if you didn't get it, that could mean that maybe you don't have access to Brightspace at the moment, right? So that should be like an indication, like maybe go to IT to get that fixed. There is an app for Brightspace too. It's called Pulse. I believe they have it on both like Android and Apple. So yeah, you guys can download that, as needed, and then you'll get all the messages for all your classes. Yeah. CUNY BCC. Yeah. Yeah, that's why. Yeah, that happened to me too when I first got it. Go ahead. Yeah. Yeah. Yeah, CUNY. I'm also at IT, they can help you do all of that too. You know, they're really packed. I would go in person. I would go in person. Like, especially this week is like I can't even imagine what it looks like over there right now. Yeah. Yeah. If they have time. Yeah. Um, da da. See what else I'm leaving out. So again, I'm Chris Lee. I'll be a professor. This is my email right here. So it's just my first name. So Christopher dot Lee, Lee 02 at bcc.cuny.edu. So if you guys ever have any questions, you can shoot me an email. If you guys are into Microsoft Teams, you can use the same email to find me. A little bit about me. Years ago, I was sitting in the same seats that you guys are. I'm alumni to BCC. You know, graduated from here, went on, got my next degree and all that, and now I'm a professor. Full circle. I'm also a tutor in the department as well. So you guys can book time with me when the calendar decides to appear, right? If you want to, no pressure. I'm not offended if you guys go see another tutor for help. That's fine, as long as you guys understand at the end of the day, that's what's most important, right? Um, that's that. Tutoring is in, bless you. Tutoring, right? It's gonna be in physically, it's in CPH, right? Room 303. CPH is that building with the arch in front of it. Like that like I don't know if I could draw it. I'm not an artist here, but it looks something like a canopy or something like that. All right. Like if they call it the potato chip building because it looks like a Lay's potato chip, you know? Yeah. So that's the building over there. It's the same building that nursing is in, right? So on the third floor, that's where tutoring physically is, right? There is also online tutoring, as I mentioned. So the way that online tutoring works is there's going to be a link. I'm going to send that to you guys. And when you click on this link, you can make an appointment online. And when you make the appointment, it's going to send you an email. And then inside that email is going to be a Zoom link. And then inside of that Zoom link, that's where they do the tutoring. All right. If you want to do it online. All right. But in person, you just go to 303 and that's it. They like if you can do an appointment to go in person rather than just walk in, but you can just walk in, right? Because I understand sometimes you have just one quick question, you just want it answered. Walk in if you don't have time to make the appointment. That's okay. All right. So 23.5, right? So we're going to be doing probability and statistics, right? Basically, what we're going to be doing is learning about data, right? And how to analyze data and how to make sense of it in a nutshell. Just kind of summing it up like real nice and simple. This is going to be a fun course, all right? I'm going to show you guys the syllabus, but I will also post it for you guys later on. Sorry. Oh, that's outside there. You know what? I should probably show you guys how to get the syllabus. How about that? So if you Google BCC and math, right? Then you'll get the link to the math department, right? And then once you're in the math department, let me just go to the math department. This is it. You can go to where it says degree program and courses, right? I am gonna post this all on Brightspace, by the way, but I'm just showing you in case you guys have future classes and you want to know where they are and all of that kind of stuff, you know? But you scroll down to your class, 23.5, right? And then here's our syllabus right here. We could just review this real quick. I'm not gonna go too in depth because you all will have it, right? But here's our syllabus, all right? We're gonna be using this textbook here. You don't have to buy it, right? I'm just gonna give you all the lecture. You just watch it, do your homework, and you should be good. All right? So course description. So this is probability and statistics course with elementary algebra, topics integrated to support with statistics. So probability and statistic topics include organization and presentation of data, measures of central tendency and variation, correlation and linear regression, elementary probability, the binomial normal distributions, those are fun, sampling distributions, the central limit theorem, confidence intervals, student t distribution, and hypothesis testing. All right. So we're gonna excuse me, we're gonna be mostly focusing on that, but excuse me, sorry about that. Sorry. But in between we'll do some little arithmetic and stuff like that. All right. Mostly I'm gonna be showing you guys how to do it on the calculator, but I will also show you on how to do it by hand, because I know some people, right, they're gonna have to do that in the future, right? Not naming out names, but all right. Here's some of our student learning objectives. Y'all can read about that. This is fulfilling the pathways required core B requirement for everybody. Here's where I was telling you guys about disability service, right? It's in Low Hall room 211. This is their phone number. This is their email. All right. So if you had accommodations in the past and you want them, contact them, right? If you want accommodations and you never had them, contact them, etc. Right? And this will extend to all your classes if you do contact them as well. Also, another note, right? Accommodations, right, are confidential, right? So if you do choose to get them, right, they don't follow you. Nobody knows that you have it. It's up to you to tell someone if you want to that you have it, right? I was a disability tutor, that's why I know about that. All right. This is our syllabus right here. Yikes. All right. So this is all that we're going to be doing this semester. All right. And then all your homework will be online once again. You just go on, log in and do it. Again, I'm going to show you guys how to do that. Let me see. I'm going to give you guys the link, but how I like to do it is I Google BCC and web work, and then I just search for the class. This is a huge list, so I use the find function, Control F. I just type in the year, type in what semester this is. So this is fall, right? And then the beginning of my last name, which was like Lee, so L, right? And boom, that's you, D16, right? I'm gonna send out this in an email to everybody. Your username and password is your first name and then your last name. No space, no dot in between, just your first name and then your last name, all in lowercase. That's your username and your password. All right. Again, I'm gonna send you out a link. So if you didn't catch that, it's okay. For those that just walked in, I didn't mention this earlier, but I like to record my lectures. So this is actually being recorded right now. So I will send you guys out the link and you guys can rewatch this tomorrow, whatever. It'll be up. So, like just watch it and then knock out the homework, no problem. Mhm. Go ahead. Mhm.
Not sure if can we see this homework on your post?
No, no. So this is a separate website, right? But in Pulse, you'll have a link that'll take you here.
Oh,
Yeah, yeah, yeah. And then you just log in and that's it. Yeah. I didn't post the link yet, but I will post it. All right. So that's that. Oh yeah, oh yeah. I didn't get to that part yet, but yeah, you'll get credit for that. Yeah. Nice. Mhm. Oh nah 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 nah. Nah 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 nah. I don't do that. I don't do that. So I'm gonna post this on Pulse or whatever on Brightspace later, but just to show you, and I really did turn that off, didn't I? Okay, 1 second. Sorry about that. I mean, this one of those places where it's like you got to pick your poison, right? You want to be too cold or you want to be too hot, you know? I mean, Meister, since the summer, Meister's been pretty cool, you know. Where was I yesterday? I was in Roscoe Brown yesterday, and it was crazy hot. Like complete opposite. Complete opposite. Like, but I hear you though. It is cold. Yeah, yeah, I got you. So this is going to be the grade breakdown for us. All right. So our final exam will be worth 33%. All of our in-class tests will be worth 30%. And then your homework is going to be worth 37%. All right. So simply put, how do you get an A in the class? Get 100 on everything. All right. But more interestingly, though, how do you get a B in the class? Right? My favorite strategy to get a B is give me 100 on the homework. And if all you could do is give me a 50 on every exam and the final, that's a B. Can't beat that, right? Right. Yeah. Yeah. Go ahead. No. Also, what choice would be so hard? Yeah. Yeah. What? It does? So, so you know what? It's funny. It's funny you mentioned that because I didn't even get to say this, but you're gonna have a formula sheet in this class, right? So you get yeah. Really? Yeah, it's like I don't know the answer, but I don't want not the answer, but the answer is right because I accept it because I don't want to show my work. I got you. I got you. We'll work on that. We'll work on that. Also, you guys get a calculator as well. So I'm not saying you don't need to memorize nothing in this class, but you will have your formula sheet, and then you'll be able to go from that. I will post it, what you call it, online on Brightspace, right? And then you guys can print it, and then use it for your homework, use it for your test, etc. Right? On test day, if you guys don't didn't remember to bring it, I'll print out some and then I'll have it here. No pressure. All right. So yeah, it'll be real cool. Don't worry, don't worry. Yeah, so that's our grade breakdown. Anybody have any questions so far though? Or are we good? Good. All right. So I know I got some what you call it, messages to send out to y'all. I will send them out, I promise. All right. So let's jump into this. All right. I'm gonna start y'all off real simple. Like we going back to basics today. All right, but we gonna build after this. All right. So first thing we gonna talk about is fractions. All right. I'm going real simple with y'all. Yeah. It's all good. It's all good. Y'all probably a lot of y'all probably know how to do this already or have seen it. What the hell? What's this happening to me?
Like you're cooking fresh. So the money, the friend.
That's true.
When he is the singing stuff, so I'm crying.
Oh no, we get into that too. Don't worry. We gonna get to that too. Hold on. Little technical difficulty, but nothing that we can't overcome. Hi, come in. You joining our class? Awesome. Welcome, welcome, welcome. I know it's a little cumbersome to find the place and everything, you know. Yesterday I went down the other side and I went all the way to the back and I was like, yo, where am I at? You know, building looked like a H, you know, like all right, so let's talk about fractions, right? So growing up, the first numbers we encountered are whole numbers, right? So we all know what whole numbers are, 0, 1, 2, 3, etc., right? So these numbers, with the possible exception of 0, are as concrete as a number can be. While I may not be able to picture a 3, I have a clear idea of what three books mean, right? $3, three fingers, etc. So the whole numbers together with their opposites, the negative whole numbers, are called integers, all right? So that's what we're getting into. So as soon as we start dividing whole numbers through though we encounter the problem that the quotient of two whole numbers may not be a whole number. A fraction is a symbolic way of writing a quotient, right? So a fraction literally just means division. Keeping it simple like that, right? Which is the result of dividing two numbers. In this way, the operation of division is built into the notation of a fraction, right? So that little line in between the two numbers, it means division, all right? Let me see if this works now. If it don't, we'll improvise. All right, we're gonna have to improvise. 1 second. No problem. We'll make it work. So, for example, right, 1/2 is a symbol representing the number that results by performing the operation 1 divided by 2. So, some things to notice right away, right? A fraction is one symbol consisting of two numbers separated by a bar, the bar representing the operation of division. One number is written above the bar, that's called the numerator, and the other number written below the bar, right, that's called the denominator. The two numbers play different roles. After all, division is not commutative. So 1 over 2 does not give you the same result as 2 divided by 1, right? Right. So 1/2 is not the same as 2 over 1, right? For the first few chapters, right, we're going to look at rational numbers. A rational number is the result of dividing two integers, right? So a rational number is a number which can be written as a fraction whose numerator and denominator are both integers, right? All right, so remember that since the division by 0 causes very fundamental problems, the denominator of the fraction represented in a rational number must not be 0. So long story short, it's illegal to divide by 0, right? Can't divide by 0 on the bottom, right? On the top is cool, right? So like 0 over 8, cool, right? But 8 over 0, no, 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 that's not true. That's not true. All right. All right. Again, for your homework, I'm still setting that all up, but I'm gonna get that to you later today. Don't worry. And yeah, your homework is just adding, subtracting, multiplying, dividing, in case y'all wondering. Right? So y'all could probably knock that out like no problem. All right. So fractions are not the only way to represent the result of division. Using long division, the quotient of two numbers can be expressed in decimal notation, right? So let's do 1 divided by 2 and let's look at that, right? And changing from a fraction to a decimal notation, to change a fraction to a number in decimal form, right? You perform long division or the numerator by the denominator. So long story short, here's what I'm talking about. If I have 1/2, right, I can change that into a decimal by dividing it out, right? So the denominator goes on the outside. That's going to be your quotient, right? Numerator on the inside. And you just go ahead and do your division, right? 2 goes into 1 how many times? 0 times, right? So you write your 0 up here. Then 0 times 2 is just 0, right? And then you want to subtract this, right? 1 minus 0 is 1, right? Put your decimal point here, right? And then what you do on the bottom, you got to do on the top right here, right? And then you have imaginary 0. Imaginary 0, right? Bring that down. So now 2 goes into 10 how many times? 5 times, right? All right. And then 5 times 2 is 10, right? You subtract that, boom, we got 0, right? So what does that mean? That literally means that 1/2 is equal to 0.5. And that's how you go from a fraction to a decimal. Questions on this? Y'all bored?
You make it seem
That's
so
good.
simple,
Yeah.
like small numbers.
I mean, even if it was big numbers, I'd do the same process. All right. Believe it or not, this little example right here, this is what people call hard in nursing. This is the hard part of nursing right here. You know? But like if you just learn this, the rest of nursing is easy, you know. A hard one, I got you. It's coming. I got you. It's coming. Always. Even if it was improper fraction, proper fraction, always. You know, always.
Well, I feel like examples are more helpful for me than like a written explanation. I don't know why.
I got
They're
you.
just way more helpful.
I got you. We gonna be doing those two. First, I like to tell you how to do it, then I show you. Mhm. Yeah. All right. So one of the unfortunate features of decimal representation of numbers is that they may not terminate nicely, right? So let's look at as the previous example did. So for example, 1 divided by 3, right, is the same as 0.333333333. It doesn't stop, right? So basic fact of rational numbers, however, is that their decimal representation must either terminate or must repeat, right? All right. I thought that was a fire drill. I'm like, that's class. Like I mean that kind of thing happens in Meister from time to time, fire drills and all that. Mhm. So yeah, let's take it up a notch, right? Let's look at the hard one. All right. Oh no, no, no. That was just the beginning. Yeah. But we gonna get there. We gonna get there. Baby steps, baby steps. All right, so other conventions, mixed numbers. So you may recall that fractions whose numerator is smaller in magnitude than the denominator is called a proper fraction, right? For this reason, a fraction whose numerator is greater than or equal to the denominator is sometimes called an improper fraction, right? However, there is nothing improper about improper fractions at all. We will work with them routinely. In fact, in most circumstances, it is better to work with improper fractions than their alternatives. All right. Me personally, I like fractions, but I am letting you guys use calculators. So if you give me decimal answers, that's cool too. All right. Da, 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 da. Where did I leave off? All right. However, there is another common way of expressing improper fractions, right? These are what are called mixed number. So a mixed number has an integer part and a proper fraction part. To convert from an improper fraction to a mixed number, we're going to perform the indicated division, right? The quotient will be the integer part of the mixed number. The remainder will be the numerator of the proper fraction part, and the denominator is the same as the denominator of the original improper fraction, right? Let's take a look. Let's take a look. So I'm thinking about, I don't want to make it too hard. All right. Let's look at 22 divided by 7. All right. Not too bad. Literally the same process that we just did before. Nothing changed, right? So my denominator goes on the outside, numerator on the inside, just like that, right? So now 7 goes into 22 how many times? 3 times, right? So put a 3 up here. Now 7 times 3 is what? 21, right? Then we're going to subtract this. 22 minus 21 is what? I appreciate y'all. Y'all don't see me, but I'm over here on my fingers like, yo, what is it? All right. Put your decimal there. What you put up, what you do on the bottom, you do on the top. Imaginary 0. All right. Bring that down. Now 7 goes into 10 how many times? Once, right? Now what's 1 times 7? 7. All right. Y'all good. Y'all good. I was thinking about that one in my head. All right. So now 10 minus 7 is what? 3. All right. That's good. That's good. Let's keep it going, right? Another imaginary 0. Bring that down. 7 goes into 30 how many times? How many? 3, 4 times, right? All right. And then 7 times 4 is 28. All right. And that's a 2. Bring down to 0. All right. 7 into 20. What's that? What is it? 2 times. All right. And then 2 times 7 is 14. Let's subtract. What is that? 6, I think. All right. Imaginary 0.
It's never gonna stop, is it?
It's never going to stop, right? It's all right. We'll round it off after this. All right. So 7 goes into 60 how many times? I hope y'all know, but I don't know.
47, 49,
49.
I think maybe.
8 times? All right. Let's go with that. And what's 7 times 8? 56? All right. Y'all get the gist, right? And then you can round off your answer after that, right? So I would say that 22 over 7, right, is equal to, let's say, 3.143, right? Go ahead. So what I could tell you about this, right? If you have a question that tells you to round off at a particular point, let's say in this case is the hundreds place, right? You want to do your math out to the thousands place so that you know what the hundredth place will be, right? So you could use that as a stopping like criteria and all that, right? I know in like certain nursing questions, they'll actually tell you, round to the nearest tenth or whatever, right? Not because it's math, but because that's what the machine does, that's what the machine understands. Um, yeah, so if you were rounding off to the nearest tenth place, for example, you do your math out to the hundredth place, and then you round the next one off, right? Okay, don't worry. Here's the trick, right? If the next number is 5 or bigger, then you round up the other one, right? So in this case, right, my next number here was 8, right? You're right. The 2 became a 3 because of that. That's it. Yeah. Oh, interesting thing, right? Why'd I choose 22 over 7, right? You guys ever heard of pi, right? That's literally pi. That's why it wasn't stopping, you know? Yeah. Really? Yeah, pi date. So if you take like a circle and the circle was like measured, I think 22 units in like circumference, right? The diameter would be 7, and that's how they come up with pi, 22 over 7. I don't know. I'm a math nerd, so whatever. What were you gonna ask? I'm sorry. Got you. Exactly, right? Because it's less than 5. Yep. Yep. Go ahead. Yeah. 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 Hmm. So that's that. Two. Another way we could have done this. Let's try this one more time because that's the decimal way of doing it. Let's say that I wanted to do a mixed number. Same thing. 22 over 7, right? Here's the difference between this now. 7 on the outside, 22, right? 7 goes into 22, we know 3 times. 7 times 3 is 21. Subtract this is 1, right? If we wanted to change this to a mixed number now, here's how the mixed number would work, right? The answer right here, that's going to be your big number, right? Your remainder, the remainder right here will be on top, and your divisor, right? Divisor will be the denominator, right? So that's how to go from an improper fraction to a mixed number. All right. Questions on this? This might be like the first and last time you see this. So just let y'all know. But we're not really gonna be doing mixed numbers, but I just want y'all to have the information, you know? All right. But let's talk about it a little bit before we jump off of it. Not gonna lie, I'm over here like faking it, but like I'm cold too. Not gonna lie, I'm keeping 100 with y'all. Right? I feel you. I feel you. I feel you. Man, but it'd be a blessing if this was a summer class, right? All right, so notice that 3 and 1 over 7 actually means 3 plus 1 over 7, right? So I want y'all to like intake that a little bit. So this is an unfortunate notation since normally the absence of a symbol for an operation between two numbers implies multiplication, right? So whenever you have two numbers next to each other, that implies multiplication. You're going to see that in the formula that we're going to be using in the class later on. All right. Anyway, but at this point, the notation is a historical fact of life. To convert from a positive mixed number to an improper fraction, multiply the integer part by the denominator of the fraction part and add the numerator to the fraction part. The result will be the numerator of the improper fraction. Excuse me. The denominator of the improper fraction is the same as the denominator of the fraction part of the mixed number. So something easy. Let's look at 5 and 2 over 3. So this is the reverse now, right? I want to go from a mixed number to an improper fraction, right? So I kind of think of this as like a kind of like a circular method, so to speak, right? So I want to do 5 times 3, which is what? 15. All right. So we got 5 times 3, which is 15, right? And then after you get that, right? You want to add the numerator to it, right? So 15 plus 2, what's that? 17. So my improper fraction is going to be 17 over whatever the divisor of this was, 3. So I'm telling you that 5 and 2 over 3 is equal to 17 over 3. All right. Questions on that? Good. So you take the big number, you multiply it by the denominator, and then you add the numerator to it, and then that's going to be your numerator for the improper fraction. And then it got the same denominator. Denominator don't change. That's it.
Big,
Right.
the big one was
That's fine. Like if it was like 3 and 1/3, so it'd just be like 3 times 3, 9, plus 1, 10/3. Yeah,
that.
I got you. I got you. I got you. To be honest with you, it's just the same process, no matter what number is there. If it was negative, if it was positive, same process, right? Just treat them all the same. For me, that actually really helped me in algebra, to be honest. Like realizing that a number is a number and I just treat it all the same. Like whether it's negative, positive, complex. I know y'all not gonna see that, but there's something called complex numbers. It's the same. Just treat it the same. You know? There's rules to it for each one, but yeah. Anyway, graphical representation of fractions, right? So you may remember from your youth seeing your math teacher draw pictures of pizzas on the board to illustrate the way that a fraction is represented. So throughout the this text, right, we're gonna be it's not the most convenient way, and we're gonna use another way to represent a fraction. All right. Something called a number line. Do you guys remember number lines?
Yeah.
Yeah, so that's how we represent fractions now. All right. Gotcha. So we'll be using a number line, right? In this representation, every number will correspond to a geometrical point. The key features of a number line is that it extends to infinity in both directions, right? One direction is designated the positive direction to the right, while the other is the negative direction, which is to the left, right? There is one distinguished point on the line that represents the number zero, right? Four, there is a unit distance between each number, right? With a length of one, which allows us to mark off all the points representing integers. Proper fractions, at least the positive ones, are then represented by points lying between 0 and 1, right? So if you have like 2/3 or like 1/7, right? That's going to be in between 0 and 1, right? The denominator tells us how many units to subdivide the segment between the labeled 0 and 1 into, right? And then you can shade accordingly, right? The numerator tells us how many subunits to count from zero. Improper fractions are handled similarly. For these fractions, it is more convenient to represent the number as a mixed number. Instead, by dividing the segment between the points representing 0 and 1, we divide the segment point at the point representing the integer part of the number and the next point representing the integer away from the point representing zero. So for example, think of the improper fraction 22/7 as a mixed number, 3 and 1/7, right? We can represent this number with the point 1/7 of the unit between 3 and 4, right? Blah, blah, blah. Long story short, right? If um if I had to graph this, right, on the number line, like how it shows here, how would I know where to put 22/7, right? Change it into a mixed number. And then once you get that whole number, you know it's going to be between that whole number and the next number, right? So 22/7 is in between 3 and 4, right? So if I was doing a number line, right, I would do like, let's say, the number three, the number four, the number five, six, seven, etc. Right? And I know that in between the 3 and the 4, that's where I'm gonna put the 3 and 1/7. Right? If you want to be like more precise, right? the fact that this number is being divided by seven, that means that there's going to be seven sub intervals between three and four, right? And 22 over seven is going to be at the first sub interval between them, right? If it was like remainder two would be at the second one, etc. Right? Just giving y'all some knowledge. Not gonna ask y'all to do this, but just so y'all can know. All right. Maybe for homework, y'all get a homework question just to reinforce it. All right, now let's talk about equivalent fractions. This is kind of important. All right. Well, it is important. Let me not say that it is important. All right. This will come up on your homework as well. So one of the most important features of fractions is that two different looking fractions might represent the same number. So when you think about it, this shouldn't be a big surprise. After all, there are many different division problems that give us the same result. For example, 9 divided by 3 is the same as 6 divided by 2, right? Both answers are 3, right? That's one way to see that the fractions 9 over 3 and 6 over 2 are different ways of symbolizing the same number, right? Two fractions are called equivalent if they represent the same number, right? So the basic principle we will need to keep in mind is the following, right? Multiplying or dividing both the numerator and the denominator of a fraction by the same non-zero number gives an equivalent fraction, right? In fact, the procedure amounts to multiplying a number by one, which of course does not change the number, right? So there are two main reasons that we will be interested in equivalent fractions: writing fractions with common denominators and writing fractions in simplest form. All right. So yes, that's exactly what I'm describing here, reducing it. All right. To be honest with you, I'm not a fan of reduction in the class. Like I would prefer like a large fraction answer, you know? But if you want to reduce it, your calculator gave you a reduced number, go for it. All right. That's fine. So writing fractions with common denominators, as we'll see below, there are many situations when we would like to write two fractions in an equivalent way so that they have the same denominator. All right. So let's say I have 3 over 10. Oops. And mm, what's a good one? Let's say 7 over 15. How about that? All right. So I want to make it so that these two fractions have the same denominator. Right? That's my goal, right? I want to make it so that they have the same denominator. An easy way to do this, right? This is gonna seem real simple because I know you guys can probably tell what it is by looking, right? But how I like to do it when I have like really complicated numbers, I like to do something called prime factorization. So basically, I take each number, 10 for example, and I figure out which two numbers multiply to give me 10. So what are they? 5 and 2, right? Now, 5 and 2 are prime numbers, right? A prime number is divisible by one in itself only, right? Let me do the 15 now. What two numbers multiply to give me 15? 3 and 5, right? Now, 5 and 3, these are also prime numbers, right? So, what I'm trying to do is find the LCD, right? The least common multiple. Here's how you do it. It's real simple, right? You take one of the numbers, right? I'm just going to take the 10 because that's the closer one, right? The 10 was what? 2 times 5, right? I should put a comma there. It was 2 and 5. Now you look at the second number. The second number has a 3. I don't have a 3 in my set yet. and it has a five, but I already have one five, so I don't need to put another five back, right? If you multiply these together, two times three times five, what do you get? Or two times five times three, whatever. What do you get? 30, right? So that right there is my LCD, right? So if I wanted to if I wanted to make these fractions have the same denominator, that denominator needs to be 30, right? That's the least common multiple that it could be. Here's how I would make that a 30. I have 3 over 10, and I have the 7 over 15, right? I want to change the 10 into a 3. So what number could I multiply the 10 by to make it 30? 3, right? But here's the thing, what you do to the bottom, you got to do to the top. Yeah. Got to be fair, right? Same thing with the 15 side, right? I want to change that 15 into a 30. So how do I do that? Times 2, right? But we got to be fair, right? What we do to the bottom, got to do to the top. So now what do I have? I have 9 over 30, and I have 14 over 30. And that's it. Questions on this? We good? All right. So in a nutshell, that's how you find the LCD. Go ahead. No problem. I do the same steps, right? So I take, yeah, so I take whatever denominator I have and I break it down to its basic prime factors. And then I just count them. I just put them all together, and then I count how many of one number is there or not. Right? Yeah. Right. So here's another scenario. Let's say that in the 15 I had two fives, right? But in the first number I already had one five, right? Then in the LCD I'd have to add the second five in there, you know? So I'm just counting numbers. Like that's the easiest way to do it, you know? I know some people could look at this and be like, "Oh, that's 30," but for me, that's how I do it, Yeah. All right. So let's talk about the reverse of this then. So writing fractions in simplest form. So a fraction is said to be in simplest form when the numerator and denominator have no factors in common except one, right? So for example, 8 over 52 is not in simplest form since 4 is a factor of 8. So since 8 equals 4 times 2, right? And 4 is also a factor of 52, which is 4 times 13, right? When dealing with large numbers as numerators and denominators, it's sometimes helpful to see their prime factorizations. We will not emphasize that here, but most of the time we'll be able to see common factors without much trouble. Go ahead. And this formula from the fraction is no more you can't read. Exactly, right? In a sense, I'm kind of showing you guys how to do this stuff by hand, but I know on the test it's timed and all that, so y'all could, crunch your numbers on the calculator, no problem. Right? You're welcome. You're welcome. Yeah. It will be. Yeah, it will be. Yeah, it will be. Yeah. It's gonna I'm gonna give you a link to like a YouTube video, and then that's where it's gonna be. Yeah, yeah. Also, just to let y'all know, I don't know why this is, but it takes me a long time to put up like a YouTube video. So like, don't like think that like, all right, class ended and I'm gonna see it in the next 10. No, no, it's gonna take me a while to get the video up. Yeah, yeah. With the voice. Yeah, with the voice. Yeah, yeah. But I don't know why, but it takes the computer or whatever a long time for me to get it uploaded, you know? But it will be uploaded. It might not be 5 minutes after class, might be sometime late at night, but you guys will get it. You know? Either way, though, like you'll have it for the weekend to watch again and do your homework, etc., etc. You know? And I do apologize to you guys in advance for tutoring starting so late. It doesn't start till the third, you know. So for right now, just kind of rough it and get through this. But after that, you guys will be able to go to tutoring and do your homework there and stuff like that. And I really encourage that too, you know. All right. Let's talk about operations with fractions, multiplying and dividing. So now that we have reviewed some basic properties of fractions, we will review the rules for performing arithmetic operations using this symbolicism, whatever. We will begin with multiplying and dividing. That might seem strange if you think that adding and subtracting are easier operations to work with, but since fraction notation is based on the operation of division, it should not be too hard to believe that multiplying and dividing are much more suited to the notation than adding and subtracting. All right, multiplying fractions. Woohoo. All right. So multiplying whole numbers has a clear relationship to the operation of addition. For example, 2 times 3 means the same as 3 added together 2 times, or 3 plus 3. All right. However, if we want to extend the operation of multiplication to fractions, negative numbers, and other more exotic numbers, right, we have to make sure that certain basic properties are preserved, like the commutative and associative properties, right? Commutative, 2 times 3 is the same as 3 times 2, right? Associative, 4 plus 2 is the same thing as 2 plus 4. That's all it means, all right? Addition and multiplication. Yeah. So commutative is multiplication. It doesn't matter the order that you multiply two things in, it's the same answer. Associative is addition. It doesn't matter the order that you add two things in. Like the answer is the same kind of thing, right? Um, so, which in the case of whole number multiplication are just easier consequences of the corresponding properties for addition. In addition, multiplication and addition must be related by the distributive property. All right, we will not review these properties here, but we will only mention them to indicate the rules of multiplication and division are not arbitrary, but are carefully constructed so that all our basic operations interact in the same way. We expect them to be based on our experiences with whole numbers. Cool. All right. Kind of running through it because I feel like y'all get it. But y'all could like slow me down if y'all want. All right, but here's the sauce anyway.
Just remembering the term.
Mm,
Wait,
if you need to remember it, just watch the video again. Like, you know, I'm not gonna like be there like, yo, what's the meaning of multiply? Like, nah. I'm gonna just give y'all two numbers, be like, yo, multiply it. All right, anyway. So the product of two fractions is a new fraction whose numerator is the product of the two numerators and whose denominator is the product of the two denominators, excuse me. Right? So blah blah blah. Let's look at what we're talking about here. All right? If I have like 2 over 3 times 4 over 5, right? What I'm trying to say is the way that you multiply is you multiply straight across, right? Numerator by numerator over denominator by denominator, right? So this becomes what? This becomes 2 times 4 over 3 times 5. All right, y'all gotta help me out. What's 2 times 4? 8. Appreciate that. And what's 3 times 5? That's amazing. And that's it. Questions on this? Good? All right. It's a Yeah, go ahead, man. It's the same process no matter what the numbers will be, you know? So this is what I'm saying. Like if it was a decimal times same thing. If it was a complex number, etc. That's it. That's all we could do. Yeah. Because we can't reduce this. anymore, right? But if there was a reduction, we'll get to that. So I gotta do little tricks like that and reduce, you know? Matter of fact, let's talk about that.
The simplest one.
Mm-hmm.
That's what you were talking about with the A over 50.
Yeah. Mm-hmm. Let's look at this. Say I had 1/4 times 2/3, right? Now, y'all good at multiplication, so y'all could just go ahead and do this, right? Me, not so much. So I got to reduce it before I start multiplying it, right? So how do I reduce it? This is how. You know, this is going to become what? 1 times 2/4 times 3, right? But I could reduce the 2 and the 4, right? 2 goes into 2 how many times? Once, right? And 2 goes into 4 how many times? 2, right? So now my top is what? Just 1 times 1. What's 1 times 1 again? Appreciate y'all. Thank you. And what's 2 times 3 again? 6. All right, y'all the best. All right, and then that's it. All right.
That is so complicated.
It does? Okay.
Yeah.
You're you better master this because you're allowed to do this in pharmacology. Yeah. Mhm. The second part, if you want, you could go, you just do it straight. If you want to do the 1 times 2, yeah, I got you. I got you. If you want, you could go ahead and do it. 1 times 2, 2, 4 times 3, what's that, like 12? You could do that if you want, but then you got to reduce it, you know? So 2 goes into 2 ones, 2 goes into 12 6 times. And now you got the 1/6, you know? I like to do it this other way though, because sometimes them numbers get real, you know? And then y'all know I don't know my timetables. So I'll be struggling, you know? Yeah. Yeah. If my feet wasn't frozen, I'd be counting my toes up here. You know? Yeah. Right. Let's try another one real quick. Say I got 15 times 4/7. All right. Damn, that's a whole number times a fraction. And we only talked about a fraction times a fraction. So how could I change that 15 into a fraction? Over 1, right? So I can rewrite this as 15/1 times 4/7, right? And then after that, just do what you know how to do, straight across, right? Straight across. It was 15 times 4.
60.
It's 60. Very good. You're gonna go far in life. That's good. What's 1 times 7? I'm impressed. All right. And that's it. Questions on this? Good. All right. I got you. No problem. No problem. Take your time. You said it was too easy. This is your homework. Like legit. Yeah, yeah. I haven't like posted everything yet, but I'm gonna send y'all a message with how to log in and all of that. Mhm. I did tell you guys how to log in, but I didn't send it to y'all. Go ahead. Really? But it's so easy. Promise you, it's the easiest class y'all have. I'll tell you which class was hard. What's the name of this class now? It was so hard I forgot the name of it. Um, Sociology. Yeah, you taking that, right? Yeah. Uh, I don't even remember. Yeah. I don't remember who I had, but I took it here though, right? That joint was hard. I got an A+ also, but that joint was hard. I was I was up all night reading. I was like, had to do a 12-page paper at the end and all that. Like, yeah, type like yeah. Yeah. And worse, I had to do it before ChatGPT. So like, yo, it was bad.
Yeah.
The fact that you realize that is going to take you far in life, right? So you could type in stuff in there to help you brainstorm, but you should never type it in and tell it to write you the paper because it'll never do it right. You know? Yeah. 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 But if you want to like brainstorm ideas and develop a thesis statement, that's what you use it for, you know? Yeah. Yeah. Outline, you know? Yeah, yeah. You know what's one way I like to use it? I use this mostly with like my nursing students, right? So I would tell them to put in all of their like their textbook or their notes, whatever, and then I would tell them to write like a prompt that says like give me an outline of my notes or make study cards for me or whatever, and then that's how I would tell them to study, my favorite way to do it. Hmm?
Research after they do it, because that ChatGPT, a lot of shit is not legitimate.
Well, if you use it, like if you tell it like, all right, do it for me, all right, that's gonna mess you up, right?
Yeah.
But if you feed it the information and then tell it to consolidate it for you, now it's official, Yeah. Yeah. That too, it could do that as well, Yeah. Yeah. I mean, I like Grammarly for that, for like proofreading. Like Grammarly is really fire for that. Yeah. Yeah. Grammarly's free too. There's a pay version of it, but like leave that for when y'all go to grad school to get y'all PhDs, Yeah. Yeah. But in undergrad, the free version is more than sufficient, you know? Mm. And you can also use it for math. I'll get into it a little bit later in the course, but when long story short, you can type in questions and ask it to show you step by step how to actually do it, you know? Asking it for they have some apps that do that too. Yeah. Like how can I say this now? Asking it to give you the answer doesn't really help you, Because like it's not there with you on the test, you know? But asking it to show you step by step the procedure of how to do it, and then you just apply that same procedure to all your homework, that's how you get through the course right there. That's the A right there, you know? Yeah. Yeah. You're welcome. You're welcome. And then we'll do some examples later on, right? Like this basic stuff. So anyway, dividing fractions. Let's look at that. So to divide fractions, we will take advantage of the fact that division is the opposite of, or more precisely, the inverse operation of multiplication, right? In order to take advantage of this fact, we will recall the idea of the reciprocal of a number, right? Reciprocal is like the flip, right? So two numbers are reciprocal if their product is one. That's how you prove if they're reciprocal or not, right? In practice, to find the reciprocal of a number written as a fraction, we interchange the numerator and the denominator. That's simple, right? So just to show y'all,
You say product, that's some.
multiplication. Yeah, product is another word for multiplication. So 2/3, right, is the reciprocal of 3/2, right? So anytime you hear reciprocal, you just flip it. That's it. All right. So that's what that means. Um, oh, I did. Ooh, ooh. It was nah. It's the temperature. That's what it was. Help me out real quick. What's the reciprocal of 4? Mm-mm. So 2/3, the reciprocal is 3/2. So the reciprocal of 4 would be 1/4. Very good. All right. Why is that? Because 4 becomes what? Exactly. And then the reciprocal of that would just be 1/4. All right. All right. I think y'all get it. Y'all should be good for y'all homework. Where is this? Okay. I'm sorry? Daily. Yeah. Yeah. You know this stuff? Okay, good, good. I mean, but like, if y'all had like 10 problems like this, is it so bad? You know, like, that's all it is. Nah. Even if I made these numbers 100 over one, y'all, it's the same stuff, you know? So dividing fractions, right? The quotient of two fractions is the same as the product of the first fraction by the reciprocal of the second fraction, right? So for example, if we write 3/4 divided by 2/3, I'm telling you that that's the same answer as 3/4 times 3/2, right? So to divide fractions, you change the division to multiplication and you flip the denominator, all right? That's how we divide fractions. Doo, doo, doo. Matter of fact, let's do this out just for the practice. Why not? All right. 3/4. Mm-hmm.
Just change it.
Mm-hmm. You flip it and change the division to multiplication. So 3/4 divided by 2/3 could be also written like this, right? Don't be scared by that. It literally just means 3/4 divided by 2/3. And then you change that division to multiplication. So 3/4 times, and then you flip the other number, right? So this becomes 3/2. I keep writing 3 on the bottom. That's the process. Right? That's how we divide fractions, right? So we always multiply by the reciprocal, right? And then just do what you know how to do. 3 times 3, 9. 4 times 2, 8. That's it. We're good. Questions on this? You good?
Like when the math starts mathing, I just start getting lost.
Really?
Yeah.
All right, let me give you an easy one. Let me give you an easy one. Let's say I got 7/8 over what's a good number? Let's say 3/4. How about that? You guys try it. Then we'll go over it.
They would.
Hmm? Let's remember, keep, change, flip. Hmm. That's a little trick. Keep, change, flip. I got hyped when I saw them. I was like, yo, welcome to the class. So then they left. Oh, here's what it is. Mhm. Reduce it. Reduce it. But you know, I'm not gonna reduce it because I'm gonna reduce it before I get there, right? So we good now, everybody? So this is gonna become what? 7/8 divided by 3/4, right? And then that's become 7/8 times 4/3, right? I'm gonna keep my life simple though. 4 goes into 4 once, 4 goes into 8 two times, multiply straight across. This becomes 7 times 1 over 2 times 3. Let's call that 7/6. That's it. Yeah. Exactly. Exactly.
Right, you're-
Uh, know? I don't know my timetables. I'm just faking it up here. You know?
No.
True.
That's what it is.
True, true, true.
But this is better.
See? This will help you a lot in the next class. A lot, a lot.
Let me.
Sure, sure. No problem.
I love it.
Got you.
You don't control the AC.
Uh,
You gotta plug it in and then.
I don't even think the janitors over there control it. Like that's somebody else.
They got.
I mean, it was good when we first walked in the building, but like, to sit through it is real. Let's try another one. You know what? I shouldn't even do it like that. Hold up. Let's make it harder. Yeah, there you go. Do it. Y'all try. Haven't done that in years. Mhm. That is it. Nope. Okay. Are we good? So we know that this is gonna become 15 over 1 divided by 2 over 3, which becomes 15 over 1 times 3 over 2. What do I do after that? Let's go straight across, right? So what's 15 times 3? 45 over 2, and we're done. That's it. Yep.
Wait, I was.
Yeah, that's it.
Yeah.
Yeah.
You see what I?
Now I just,
Really?
feel fucking the gear thing, I'm like, wait, you know.
Like, oh,
Right?
so I'm just like, trying to do.
If the 3 was in the denominator, then you could do it.
Right,
Yeah.
they don't go in.
Yeah. So then that's it. I could,
Yeah, that's what.
but I don't need to. Like, I'm not even gonna ask you to do that. Like,
The homework, right?
it'll be on web work. So on Brightspace, I'm gonna give you the link for it. Yeah. On in the announcements. Yeah.
First and last name, right?
Yeah, first and last name all lowercase. You guys can try and log in now if you want, but
Yeah, fine.
it's okay if you can't. Tomorrow is another day. That's fine. It's due sometime before the first exam. Yeah.
Whatever.
Yeah. Probably
You don't have to.
I gotta look it up. I gotta look it up. Y'all making me count. Y'all making me count. It's 2, 3. I think it's probably gonna be due like the 14th of September or something. Yeah.
Okay.
Yeah, I didn't post nothing yet. That's why. Yeah. Yeah. I got you. Yeah. So like the 14 around there, that's when it'll be due. That's a Monday. Yeah, I have time. Tutoring will be open, so y'all could go there, finish it, all that good stuff. Welcome, you welcome. Uh-huh.
I'm gonna add the iterate directions design into web work.
Yeah. Yeah. It's gonna be in the YouTube video because all of this was recorded. Just watch it again. Yeah.
My last class, like,
Yeah.
it's called Bright Space, but it had its own folder, like, it was top of the.
They better than me. I don't know how to do that. That's what I live by announcements. I'm just gonna be like announcement. I'll be like, yo, like test on Tuesday, stuff like that. Yeah. Okay.
Okay.
All right. It's over. It's all recorded. Oh, I forgot to do that. I'll do that next time. Go ahead. Yeah. All right. Yeah.
I think I got it with CUNY Bronx or
Yeah.
CUNY, something.
So start off with CUNY, right? And then Bronx. Next. Where did that slash come from? Oh,
It's supposed to be a
it's-
fair. There's no fair.
Wait, really?
Mm-hmm.
What is this? This Apple?
Yeah. Maybe turn the, let me see if I turn it.
It's so wonky on iPhones as well. Everything, all the apps, the websites.
Stop this.
You said CUNY what?
Try CUNY Bronx or Bronx